and let's go ahead and do it. All right, so good morning. Has anybody started the homework yet? Anybody have any questions about the homework? Yeah, what have you guys seen? If you have any questions, now is a great time to ask about the homework. I know it is not due. It's not due until tomorrow night. Does anybody have any questions?
There's this one question that I have on the homework. Like it's like I don't remember what question it was, but it was like towards the end of it. Like it was like how it was wording. Like it was like the words like and like it was like word questions or whatever,
Yeah.
and then you needed to like take like information from the question and then add like vertex and like
Okay, so number 17 and 18 is what you're talking about, and that's specifically one of the things that I'm going to address today. Number 17 and 18, and it talked about a horizontal shift and that, or a reflection over the y-axis and whatever. So that's specifically why I wanted to talk about that real quick. So before I do any of this stuff, we've already talked about what a parabola is. So we've got an axis of symmetry. That's my vertex right here, a reflection over the y-axis. That means this is your mirror, so this point would end up being one step over here. And if I was right here, it would be a reflection, so it would be over here. So if it is reflected over the y-axis first, you don't even need to account for it. So there are some kind of awkward things about this, but make sure that you make sense of the entire thing. So we're not going to really focus on, and there's something else on a reflection over the y-axis. And we're definitely not going to talk about horizontal stretches and shifts. For instance, you guys might see somewhere where we have something like this. Now, we will never, ever, ever address it where you're adding or subtracting something and there's a coefficient for x inside the quadratic. But it can happen. So remember, and this is the only time I'm going to talk about it, remember, if this ever happens, if you get to the SAT or ACT and you get here something like this, your value for x, that h value right here, hk, is always what value of x makes the quantity equal 0. So this would really be, you take 2x minus 1, set it equal to 0, and solve for x. So add 1, divide by 2. So your h value would really be 1/2, and your k value is still 3. We don't talk about that in here, but we will talk about that in pre-calculus. So there's two things. By the way, I will go over that exact question and answer at the very end of class. Okay, Elizabeth? So make sure, ask me that again. Remind me when we have like 5 minutes left, and I'll go through the answer. All right?
okay, thank you.
You're welcome. All right, so let's go through and let's do this again. Today's lesson is going to be a lot shorter, but it should wrap up any questions that you guys have on the homework. And this is really the end of our 2.1 section. So your homework you should be able to do from here. So what I want you guys to do is I want you to graph this. Before we graph, and we're going to do this together, what is my A value? What's the value, my coefficient for my quadratic quantity?
1.
It's just 1. How has this been transformed or shifted? It's been moved what? Start with that one.
Left 2.
Perfect. And
Down 1.
perfect. So what is my vertex then?
-2, -1.
-2, -1. That's exactly right. Now, so I know I'm going to go slow. We don't have a ton to do today. I want to make sure you guys all get this. So I always start left 2, down 1. I always start by graphing my vertex first. By the way, let's make sense of this. Does this open up or does it open down? And how do you know?
It opens up because the coefficient The A value isn't negative.
Exactly, because A is positive, it has to open up. So I know it's going to look something like this. But again, this is math class, and we don't just go, it's going to look something like this. We're all about exact answers. So start with your vertex, which is negative 2, 1. You already said my A value is 1, right? So here's the table. It's your number of horizontal steps squared times A equal your number of vertical steps. Now again, tomorrow we're really going to talk about axis of symmetry, but if that's my vertex, I've got an axis of symmetry right through the H value or right through that X value. So how many horizontal steps should we take here? Let's start with how many?
1.
So 1 horizontal step. Square it. What's my A value again?
1.
1 squared is 1 times 1 is 1. So from here, if I take 1 horizontal step, I take 1 vertical step. Go the other way, 1 horizontal, 1 vertical. Now what if I take 2 horizontal steps? Two squared is 4 times 1 is 4. So again, from the vertex, I go over 2, I go up 1, 2, 3, 4, over 2, over 2. And that's all you have to do. Any questions? All right, so take a second and try B on your own. I'm going to leave all that up there, but take a second and try B on your own. And by a second, I'm not going to give you too much time. I'm going to give you about a minute. All right, before I give you guys any other time, let's start with something real simple, and then I'll give you guys some more time. What is my vertex here? So my vertex is,
0, 10.
can I get somebody to confirm that or correct it?
I got 0, 10 too.
And that's exactly right. So again, nothing's happening to my X value, which means in the quantity, nothing is being added or subtracted. So that's right. What's your A value here?
-3.
-3. So let's start 0, 10. And your A value is -3. So go from there. Again, we can plug it right into this equation. Horizontal steps times your A value. So I'm going to multiply them both by -3. And you've got a choice. So take about 30 more seconds and finish this. All right. So how many horizontal steps do we want to take? You can pick anything. So what do you think we should take?
One.
Yeah, let's do 1 and let's do 2. Remember, you have to square them because of this exponent. So if I do 1 squared, it's 1 times -3 means if I take 1 horizontal step, I go down 1, 2, 3. Again, there's the axis of symmetry, over 1, over 1. If I take 2 horizontal steps, 2 squared is 4 times -3 is -12. So if I go 1, 2, go down 12. Over 2, over 2. There you go. So this got pretty steep pretty quick. By the way, when you're graphing this, make sure that they don't make V's, they make U's. They are parabolas. All right. Try the last one again. Try it completely on your own. We'll go over this in about a minute and a half. All right. Let's go ahead and do this one. So let's see. What's my vertex here on C?
1, 0.
Perfect. 1, 0. My A value is
1/2.
1/2. So 1, 0 is right here. That's my axis of symmetry is x equals 1, which we will talk about a lot tomorrow. And if my A value is 1/2, again, horizontal steps, how many horizontal steps do you think I should take this time? Should I still take 1?
2 and 4.
Exactly, 2 and 4, because we want multiples of the denominator. So 2 squared, 4 squared times A, which is 1/2, equal the number of vertical steps. This starts to get pretty easy once you understand it. So 2 squared is 4 times 1/2 is 2. So if I take 2 steps, 1, 2, 1, 2. If I take 4 steps, 4 squared is 16 times 1/2 is 8. So if I take 4 steps from the vertex, 1, 2, 3, 4, I go up 8. 1, 2, 3, 4. There you go. By the way, was that a stretch or a shrink?
Stretch.
Wait a minute. Look at the value.
Shrink.
It's a shrink. So if that A value, don't worry about the positive or negative, but if that A value is less than 1, it's a shrink. If it's greater than 1, It's a stretch. Now, I said don't worry about that. I know that that's not mathematically accurate what I just said. The negative just shows a reflection over the x-axis, right? So I just don't want to confuse you by saying something like the absolute value of A, but if the absolute value of A is -3, is greater than 1, it's a stretch. But I also understand how that can be confusing. The absolute value of A is less than 1 or a fraction less than 1, it's going to be a shrink. Again, I know that seems awkward. Like, why is that a stretch? It's gotten bigger. It hadn't. It's gotten wider. The stretch is like when you stretch a rubber band, the two ends get a lot closer together, or the middle part gets a lot closer together. All right. Now, make sure that you guys understand that. If you have questions, let me know. This is a really good look at what we're doing. Now, you don't have to write down the problem, obviously. But what if I gave you a graph and I said I want you to now write the equation given the graph? I'm going to do A with you, then you're going to try B on your own. So how this starts is by finding the vertex. Well, the vertex is real simple. What's my vertex on A?
4, -4.
It looks like 4, -3, but yeah, it's hard to count sometimes and see it, especially at these. My screen's small too, or I don't know too, but my screen's small. It's hard to see, but I've got it at 4, -3. So when I say write it in vertex form, remember those are your H and your K. Here's what vertex form is, right? So y equals a x minus 4 squared minus 3. Now we're almost finished, but we have to find what our a value is. So please watch. If you understand this, you are good to go. We take our horizontal steps squared times a equal our number of vertical steps, right? So from the vertex, how many horizontal steps did they take to get to any one of these other points? How many horizontal steps did they take? Remember, here's your axis of symmetry. So how many horizontal steps did they take to get from here to here or here to here?
1.
1. So 1 squared times a equals, and how many vertical steps did they take?
3.
That's all you need, and now you can solve for a. It's a very simple equation. If you understand this, now you can do it forwards and backwards. Well, 1 squared is 1. So this is 1a equals 3. Divide by 1, we don't have to do that. So 1a is 3, so guess what? I come over here. Oh, come on. My a value is 3, and that's it. It's actually pretty simple. I understand how this can be confusing, but this is just a little equation. So take about a minute and try B on your own. Question? Few more seconds.
Mr. Riley,
Yeah.
so you said we have to have all our stuff turned in by Friday or Monday.
Tomorrow. Well, any of your late stuff has to be done by Friday if you want it in, but remember that you only get 50% for that.
Okay.
Okay. All right. Okay. So let's go ahead and do this real quick. So what's my vertex on B?
-1, 7.
Perfect. So I'm going to go right here. -1, 7. Remember, it goes in as the opposite. Now we just have to find our A value, right? So let's do this again. If you get this, you're actually ahead of the curve. How many horizontal steps to go from here to the vertex to any one of these points? How many horizontal steps did it take?
3.
And how many vertical steps did it take to go from here to here?
3.
And now it's a simple equation. Remember, it's horizontal steps squared. 3 squared is 9a equals 3. Solve for a, so divide by 9. And 3 divided by 9 is really what?
1/3.
Am I finished? Is that a good answer?
You need to make the 1/3 negative because it opens down.
And that's 100% right. So some people said, well, you said vertical steps. You didn't say up or down. You're right, and I'm very intentional about that. It should be, if I'm going down from the vertex, you know that it opens down, therefore your A value has to be negative. So she said vertical steps. She said 3, and I didn't count that wrong. It is 3 steps. Just 3 steps down. So if I would have done -3 here, that's perfectly fine. That's a good answer. Or just make sure if it opens down, your A value has to be negative, and that's putting everything together. If you can do that, you can really do anything from this chapter. So let me go ahead and do this last thing. You don't have to write this down, but this is what it looks like in your book. If we have a vertical shrink by a factor of 1/4, followed by a translation 2 units right, 1 unit up. What does that look like? So take a second and try number 1 and number 2 on your own. All right. So again, I want you guys to pay attention. Write a rule for G described by the transformation of X. So G of X equals. It's a vertical shrink by a factor of 1/4. All that is my A value. So my A value is 1/4. Do not forget the exponent here. X goes in here. So if it's 2 to the right, is that -2 or +2?
-2.
Good. Remember, it's always the opposite of what's happening to X. And if it's 1 unit up, it will be +1. Same thing, number 2, a vertical stretch by a factor of 3 reflected across the x-axis. Means what's my A value really here?
-3.
That's it. Do not forget about the squared. So followed by translation, 1 unit left means what?
+1.
On the outside or inside?
On the inside.
That's right, because with the X, always moves it left and right, all right? Again, I said this earlier, if it says anything like this, a reflection over the y-axis, if that is the first thing that's done, you do not have to do anything. You don't even account for it because it's already reflected over the y-axis. All right? That's throwing a lot of people off, and we really don't address this or horizontal stretches and strings. They do exist, but they work exactly, they're inverses with vertical shrink. So we're not trying to throw you off, and you can really just do it as a vertical stretch or shrink. So don't worry about horizontal stretches or shrinks. Reflection over the y-axis, what it typically would look like is that the X inside is negative. But we're not really going to do that, okay? So go ahead and get your homework done. It is due tomorrow at midnight. So I'm going to stop share. Have a fantastic day. Remember, tomorrow when you guys come on, cameras on, please. Hopefully you guys are paying attention. So if we're going to be back in school in about 4 weeks, I'll have to, it'll make it out who's paying attention, who's not, all right? So I'm going to go ahead and end it. Have a great day.
Thank you.
Welcome. See you guys.